So eventually lower here, the lower operation, the branch if lower operation is the complement of the previous operation, which is branch if higher or same. All right, let's go to the last one, branch if lower or same. I think there is a mistake here in this table because C or Z has to equal to 1. So I would like you to fix this 0 here in the fourth line to make it equal to 1. Because this is exactly the opposite. This instruction is exactly the opposite of the very first instruction. See? So you just take the complement of it. So branch if lower or same, this process is the opposite to the first process, branch if higher. So higher is opposite to lower or same. So that's why C or Z should be equal to 1 here. You see? In the same way, lower here is the opposite of higher or same. You see? So that's why the C has been complemented. Here the C or Z has been complemented. So take a note of that. Please make this logic 1, not 0. We're going to get into some rotate instructions. There is some kind of little interesting talk here that we're going to go through today, summarizing the remember where we are now. Believe it or not, the material we talked about was up till slide 29 out of 55. So that's the biggest part of the chapter. It's an easy part, and that's why it went through very fast. Um, so at that point, um, I would like to deviate a little bit from the theme of the lecture and take about uh, 10 to 15 minutes talking about projects, and then I will go back to complete the rest of the chapter after a break. I will talk about uh, projects first, and then I'll go back and continue from slide 30 to slide 55. So let us remember where we are. We are at slide 30. We're going to start slide 30, the rotation.
I have a
Now let
question
me
about
take a time out and to talk about uh, the project in this course. As you know, we are going to have a project. It's not going to be a lengthy or complicated project, and well, the intention of it is to kind of stretch your imagination how you can do some design. It teaches you how to do design. It's a 300 level course, and it's not really customary in our department that students at the 300 level would do a design. But I think I would like to give you some initial concepts of design. Yeah, it's not a heavy dose of design that we're gonna do in this project, but you're gonna exercise your analytical abilities to come up with simple designs or to come up with some products that you're gonna be happy with or proud of at the end of the course. And I anticipate that this activity is gonna take like 2 weeks. You know, we are today, believe it or not, we are in the third week. We are close to the end of the third week. The first week was a half week because of the Memorial Day. So we have only 3 weeks left after this lecture. After this, after today, I should say, after lecture and lab, there will be uh, 3 weeks. Yeah, everybody is here. I would like to talk to you about design. You're not going to do a very big project. You're going to be doing a simple project. In When the circumstances are normal, there is no limitation to our imagination. We can do whatever we want with the project, but due to the restrictions, we don't have labs here. We don't have access to heavy equipment to be working with. So we're going to be limiting our analysis to kind of simpler projects which don't require heavy software. They don't require you to go to, let's say, Fry's or Best Buy or whatever and purchase components like purchase counters. Nobody is gonna ask you to purchase counters and uh, logic gates and uh, processors or anything like that. We're asking you to build simple stuff. That's why you will see some examples. I'll show you some examples for old projects. These
Professor
are,
Westy, Professor
yes,
Westy, I have like homework questions. Can you help me with them, or do you want me to ask after class?
uh, could you repeat the question, please?
Yes, I'm asking for some homework questions that I'm having trouble with. Can you help me with them, or should I ask after class?
After class. Yeah, we
Okay,
can do the homework after class.
okay, thank you.
Yeah, you're welcome. This is a possible project. I hope everybody is watching now the screen. It says traffic light control using interrupts and time delay loops. So as you can see, there isn't much of a hardware. There is a trainer. Well, here is the interrupt request pin. There is a switch. You not even have to purchase a switch or anything. Everybody has a resistor at home from previous labs, 330 lab or whatever. You guys all have resistors. Uh, If you don't have a resistor, that's not a big problem. You can just directly connect this to VDD. VDD should not exceed 5 volts. We don't want you to break the trainer. So make sure that this pin cannot be connected to, you cannot connect it to 10 volt, for example, or 15 volts. It should be connected properly, no more than 5 volt. To be on the safe side, we have a resistor here. So when you close the switch, this pin is grounded. When you open the switch, this pin is connected to VDD. So when this pin is grounded, as you will learn from chapter 8, from uh, chapter 11, chapter 11 is an interrupt. Uh, so of course, we're gonna we're finishing chapter 5 today. I don't know if we will have time to start chapter 6, but for sure 6 and 8 can be finished for sure next week. I want you to start thinking on the projects starting from this coming week. You need to form groups starting from